So this is the recording for the example data that I took for the RC circuit lab, and the numbers and measurements that are given from at the beginning of the experiment are that I had 3.18 volts on the two batteries, 96,000 ohms was the resistor I had, and notice what happens here now, right there. So it calculates that the initial current is 33.1 microamps, and the capacitance, that's what it says, was 470 microfarad, which gives me a time constant of 45 seconds. Okay. And this one here should then be confirmed by the data that I took and evaluating those data. So at 10 seconds, I got 26.0 microamps, 21.2, 17.5, 14.5, and I could have done that ahead of time, but I figure I might as well show you what happens here already on the graph, that it's dynamically calculating this graph and changing the results as I put in more data. 7, 9. Okay, so those are the data for charging the capacitor. And what these numbers mean is this is the initial current, 30.5 microamps. On one hand, that can be compared to the 33.1 microamps that is listed here. And it looks like it's about 10% off, and part of the reason is that the resistor itself has a certain tolerance to it, about 5%, and then that I just didn't hit the stopwatch at the exact same time that I flipped the switch, so that's why that's slightly off. What's important is the exponent here, the 0.019, and that's what I'm going to plug in here, 0.019, and that gives me the 53 seconds here. That's the time constant compared to the 45 seconds here, and that's also about, well, almost 20% off. And again, part of the reason is that the resistor, which figures in here, has a 5% tolerance, and the capacitor actually has up to 20% tolerance, and that easily explains why the time constant that is calculated from the beginning versus the measured one, 53 seconds, could be quite a bit off. By initial current here, that's actually the 30.5 that I should put on there. So that's how you enter the data, and of course for discharging, it's just the same. Or get the entire picture, hopefully. So practically I'm going to put in the same data, and again it calculates it dynamically. And as I'm trying to read this off here, the scribbles that I did on a piece of paper, I hope I'm not making a mistake. I ask you not to make a mistake on yours, but mine is just a demonstration. Again, I'm going to get a certain initial current. In this case, it's 29.4 microamps, and the exponent is the same as before, 0.019, which gives me the same time constant of 53 seconds compared to the other one of 45 seconds, the given one. Let me just show you what if you didn't have one data point, like you missed one or you're unsure about one or you want to kick one out. Well, I could just delete this one, and notice what happens is that one data point vanished and the equation got a little bit adjusted, but overall, I got 14 data points instead of 15, which is just about as good. In fact, notice on the equation nothing changed. It's still 29.4 microamps, 0.019 for the exponent, 53 seconds for the time constant. And that means if you have one data point less because you missed a data point, it won't matter in the end.